Hi, my name is Shay Caver, and I'm an applications engineer here at Analog Devices. In the previous video, I introduced the MAXREFDES281 and demonstrated the hardware setup and software configuration of this reference design. In this video, I'll be demonstrating how to build, flash, and debug on the MAXREFDES281 with the firmware provided by Analog Devices. The firmware provided contains examples for both the MAX22007 PMB and the MAX22005 PMB, but for this example, we will be focusing on the MAX22005 PMB industrial analog input. Before beginning, ensure that the hardware is properly set up. For instructions on how to do so, please refer to the previous video titled MAXREFDES281 Introduction and Demonstration, where the initial setup of the MAXREFDES281 is shown, and the IO-Link control tool software is demonstrated. For this example, we will be using the MAX22005 PMB, and will need to replace the MAX22007 PMB used in the prior demonstration. We will also need to connect a debugger to the reference design to flash and run the firmware. In addition to our existing hardware, we will need a MAX22005 PMB PMOD board, an ST-Link V2 debugger and ARM JTAG 20-pin to 10-pin adapter and ribbon cable, and a USB Mini-B cable for the ST-Link debugger. If you haven't done so, download and install STM32Cube IDE before getting started, and ensure that the IO-Link control tool used in the prior video is installed and opened. Start by disconnecting the MAXREFDES281 from the IO-Link cable. This ensures that the MAXREFDES281 and any downstream devices are not receiving power. Disconnect the MAX22007 PMB and connect the MAX22005 PMB to the PMOD connector. Disconnect the screen from the MAXREFDES281, which should expose the connector for the ST-Link debugger. Connect the ST-Link debugger, and then reconnect the screen. Reconnect the MAXREFDES281 to the IO-Link cable. Finally, connect the ST-Link debugger to a PC using the USB Mini-B cable. Make sure that the board is powered on using the IO-Link control tool before attempting to flash any firmware. Start by creating a new workspace folder, then open STM32Cube IDE. When prompted, specify the path to your folder and click Launch. Click on File and then click Import. Click the drop-down arrow next to General and click Existing Projects into Workspace. Then click Next. Click on Browse and then navigate to the design files and find the directory which the firmware project is located. Select it and click on Select Folder. Ensure that the Search for Nested Projects option as well as the Copy Projects into Workspace options are selected. Then click Finish. The source code can be viewed in the IDE. Files such as main.c and application.c can be modified and adapted for specific applications. An evaluation version of the IO-Link device stack library is included as well, though it is important to note that this static library is for prototyping and testing, not production. The launch files contain the run and debug configurations for both the MAX22005 PMB and the MAX22007 PMB. Select a build configuration by clicking the drop-down menu next to the build hammer. The prior example used the MAX22007 analog output, So in this example, the MAX22005 analog input will be demonstrated. Click on the project that you'd like to build, and the project should build. To run the project on the board, click the drop-down arrow next to the Run button, and then click Run Configurations. Click the arrow next to STM32C/C++ application. In this case, we'll be using the analog input MAX22005 PMB config. So click on this. It should correspond to the launch file in the Project Explorer. Ensure that the project and application are properly populated, and then ensure that the build configuration matches the run and debug configurations. Click on the Debugger tab and ensure all of the values are properly populated. Then click Run. Eclipse should build the program again, and it should be flashed to the MAXREFDES281. Once the flash is successful, use the IO-Link control tool to communicate with the board. The procedure for debugging a project is very similar to the procedure for running a project. To debug a project, click on the drop-down arrow next to the debug symbol and click Debug Configurations. Click on the desired debug configuration on the left-hand navigation panel. Ensure that the project and application are once again populated properly. Then click on the Debugger tab and make sure all the values match as well. Now click Debug. Again, Eclipse should build the project again and flash it to the board. Click Switch to go to the debug view and use the debug tools that Eclipse has provided. You can now use the debug tools in Eclipse. Click on the Resume button to run the program, and you can click on the Pause button to halt execution. You can step through the code, as well as set breakpoints in the code. When you're finished, click on the red Stop button to terminate execution. For more information, please visit our website. Our MAXREFDES281 product page contains more specifics on this reference design, including an app note and design files. Thank you for watching.